angles. Okay? So, here are some things that we might need to encounter. First of all, the definition of congruence, still a thing. Okay? But with angles, we go from the M in front of the angle when there's an equal sign, and then angles congruent. Okay? So, back and forth. We know that an angle bisector is going to split an angle into two equal parts. So similar to how we would use a midpoint, we have angle bisector. Okay? We know that two complementary angles add to 90 and two supplementary angles add to 180. We know that perpendicular means we have a right angle, and we know that a right angle means 90 degrees. Okay? So if in your given, they say angle ABC is a right angle, then your next step can be the measure of angle ABC is 90 degrees because the definition of a right angle. Okay. We also have an angle addition postulate. Okay. Much like the segment addition postulate, small angle plus small angle equals big angle. So in this picture, the measure of angle ABD plus the measure of angle DBC equals the measure of angle the whole thing ABC. Okay, every angle, what are our measures going to be between? We're going to go with 180. We will get into angles above 180 when you get into Algebra 2, which is next year, actually. Again, there is such thing as negative angles. Not in geometry, but in Algebra 2.
How is the angle 0 degrees? Okay.
Yeah. Okay, pretty much two rays overlapping. Okay. All right, what do we know about vertical angles?
They're the same.
They're congruent. Okay. If two angles form a right angle, then we can say they are two angles form a linear pair. We know that they are supplementary. Okay. With our vocabulary of linear pairs, supplementary, complementary, perpendicular, there's going to be a few more options for how we describe some of our reasons. And we'll kind of work through what some of that looks like. But I feel that segment proofs and angle proofs have a lot in common. We just have a lot more options with our angles than we do our segments because of our complementary, supplementary, those kinds of things. Okay? So, what I want you to do is I want you to look at example 1. I want you to look at the picture. I want you to look at the given. I want you to look at what we need to prove. Does it seem reasonable that if 2 and 3 are congruent, 1 and 2 are a linear pair, does it seem reasonable that 1 and 3 are going to be supplementary? Yeah. Okay. So I'm going to mark my picture to help me out. It's saying that 2 and 3 are congruent, right? Okay, so in box 1, I have my statement that is my given. How do I go from statement 1 to statement 2? So angle 1 and 2 form a linear pair. Measure of angle 1 plus the measure of angle 2 was 180 degrees. Okay, so you can say that. You can also say, since it says specifically linear pair, so you can say definition of supplementary, or in this case, we can say definition of linear pair. Okay, we know that a linear pair means supplementary angles.
Can't we use supplement theorem?
Yes, we could. So you can say this, or you could say supplement theorem. Okay. Either way, I'm cool. Okay. How about this? The measure of angle 2 equals the measure of angle 3. How did I get that? Because here I have 2 is congruent to 3. Here I have that they're equal. So there's our angle version of definition of congruence. Okay? Ooh, now I have angle 1 plus angle 3 is 180. Do you notice how here I took angle 2 and replaced it with angle 3? That's what we call substitution. This is a time where it's only substitution. Transitive doesn't make sense here. It's literally only substitution. Okay? And then to go from 4 to 5, what do you think we should put there? Definition of supplementary. See? You got it.
Oh yeah.
Oh yeah. I like the excitedness in the voice there. Ooh, this is interesting. All right. Oh, we know that 2 equals 4, right? What else do we know?
That 1 equals 3.
Okay, so let's do that. Angle 1 is congruent to angle 4, and, whoops, that's not what I meant. 1 and 3, and 2 and 4. Why? Okay, vertical angles are congruent. Okay. Now, I got this proof from our textbook. I don't necessarily think that this would be necessary, but what they did is they switched this around so that using the symmetric property, angle 3 is congruent to angle 1. And maybe they just did this to really show, like, hey, we can use the symmetric property with congruence. But what?
3 needs to end up on that side.
Why does 3 need to end up on that side?
Because our final thing is 3.
Gotcha. Okay, so what else can we say about angle 3? Who is he congruent to? Ooh, angle 2. Why? 1 is congruent to 2, so we can put that there. This is 1. I would take substitution. I would also take transitive. So now I have 3 is congruent to 2, but I also have 2 is congruent to 4.
But 2 can also be replaced with 4.
So now we have substitution or transitive. I can't spell. Okay. There's a lot more information we know about angles, and so we have a lot more different types of proofs that we're going to encounter. All right, so let's maybe do a couple that don't have any hints for us, eh? Oh my.
Oh, gee.
Perpendicular.
Oh, my God.
Perpendicular.
Gee whiz.
Okay, so let's do a couple things. Let's mark that this is a 90-degree angle, right? B, D, F. Is that what it's saying? Okay, let's also mark that 2 is congruent to 3. And we need to prove that 1 is congruent to 4. Does that seem reasonable?
Yeah. Sure.
What do you think we're going to have to do to help us out with that? Well, I would not say segment addition postulate, but I like the addition postulate, the angle addition postulate.
Complementary, that complementary.
Oh, we have some complementary things happening, right? Okay, so we know that, so let's say this. Since we have perpendicular angles, or perpendicular lines, we're gonna have to establish that we have 90-degree angles. So technically we have 4 90-degree angles, correct? But only 2 of them matter, okay? So we're gonna do the measure of angle DBE is 90 degrees. And the measure of angle EBF is 90 degrees. We're going to put definition of perpendicular. Okay. Now, let's take what you're saying with our complementary angles. Okay. So, since we have these 90-degree angles, we can say the measure of angle 1 plus the measure of angle 2 is 90 degrees. And we can say the measure of angle 3 plus the measure of angle 4 is 90 degrees. Yes, that is a squeaky chair. You don't have to keep doing that. What would our reasoning be? So either definition of complementary, you can say complementary theorem. I think that's actually like how we have it on that first page, right? But again, I can be flexible. As long as you're saying something about complementary, I'm going to be cool. Okay?
We substitute measure 2 with.
Ooh, okay, Jay, I like that. Can we substitute measure 2 with angle 3? Not right now. Why? I have measure of angle 1 plus measure of angle 2, measure of angle 3 plus measure of angle 4. Do I have the measure of angle 2 equals the measure of angle 3? No. So before I can do any substituting, we're going to have to say the measure of angle 2 equals the measure of angle 3 because of our definition of congruence. Okay? Now, when I typed up these notes, I did not give us enough spaces to do our proof. Sorry. We're going to have to write a couple extra lines in. Can you be flexible with that?
No.
And remember, just because we run out of room doesn't mean we're doing it wrong. But I will add in more for next year. Okay. So now we can substitute measure of angle 2 for measure of angle 3. So I can take this guy right here and replace angle 2 with angle 3. Okay, now what can we do?
Add another line.
Oh, yes, we're going to add another line. But I still got to get to 1 and 4 are the same. So I have this right here. 3 plus 4 equals 90. 1 plus 3 equals 90. Do you see that?
Yes.
So what can I do with those?
Oh, you can. I get it. You can substitute the 3 and the 4 into the 90.
Okay, so the measure of angle 1 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4.
Oh, and you can subtract measure of angle 3.
Man, I really messed up. Okay. Philly, was that you that said subtract?
Yeah.
That was somebody. Somebody over in that direction. Maybe it was Josh. It's definitely not Josh. Okay. So notice how both sides have a measure of angle 3. So we can subtract it from both sides and get the measure of angle 1 equals the measure of angle 4. Are we done?
No.
So close. What's our last reason?
Definition of congruence.
You know what? I'm feeling brave. I'm feeling brave. I'm going to give you a couple minutes to see if you can do example 4, you and your elbow partner. I did it in the 3 steps as long as I put both of my givens in number 1. If you want to put your givens in 2 separate boxes, then you'll need 4. Okay? Just talk through it, see what you can do.
So it's 45 and 45. No, just I love you.
Okay. What can we say since FB bisects AFC?
That
90.
AFB is congruent to BFC.
AFB is congruent to angle BFC. If that's not your second step, it needs to be. If we are given a bisector, we need to, in the next step, have 2 equal angles. Just like if we have a midpoint, our next step is we need to use, or one of the next steps. Sometimes if we have multiple givens, it might take us a couple, but with the midpoint, we have 2 congruent or 2 equal segments. With an angle bisector, we have 2 congruent or 2 equal angles. Hey, do you see how we've got some congruent angles that are kind of matching? That was quick. AFB is congruent to CFD. Substitution, transitive, flexible.